Hi, welcome back to Digital Forensics. We're going to continue on with NTFS today, and that is going to involve a couple of specifics that we're going to look at in the slides that will contain some tables and some other technical information, stuff that we won't be using a whole lot. So if we get started, what's NTFS? NTFS was introduced with Windows NT, primary file system for Windows 10, and of course all of the NT servers. Improvements over the FAT file systems. NTFS provides more information about a file. NTFS gives more control over files and folders. It allows for larger folders to be created, larger files to be created, and it also allows for journaling. And NTFS was Microsoft's move toward journaling file system. And it records a transaction before the system carries it out. So in NTFS, everything written to the disk is considered a file on an NTFS disk. First data set is the partition boot sector. Next is the master file table. The master file table contains all the information of all the files in the system. NTFS results in much less file slack space. That's the space at the end of your clusters. Clusters are smaller for smaller disk drives. Now, you wouldn't want smaller clusters on larger disk drives unless you're very concerned about saving disk space. NTFS also uses Unicode, an international data format. So it's about time they switched over to that, right? Okay, so cluster sizes and TFS disk. If you look at that table, you can look at how the cluster size depends on the size of the disk and where they go with that. If you want to sit there and pause right there and study that, go for it. That's it's a nice little thing to look at. All right, NTFS file system files. MFT contains information about all the files on the disk, including the system files the OS uses. In the MFT, the first 15 records are reserved for system files. Records in the MFT are called metadata. So if we look through this, metadata records in the MFT, we have the $sign MFT, system file MFT, record position 0, and then the description for each. So we can look through that, and that's the file metadata in an NTFS system. Remember, Windows 10 is using NTFS, and you can select NTFS on several other versions of Windows. And continuing on with the metadata, if you look through and look at those attributes, etc., then that's going to be all metadata that you can capture about files inside of the MFT. So inside the NTFS MFT, all files and folders are stored in separate records of 1024 bytes each. Each record contains a file or folder information. This information is divided into record files containing metadata. Remember, this is the master file table. A record field is referred to as an attribute ID. File or folder information is typically stored in one of two ways in an MFT record, resident and non-resident. Files larger than 512 bytes are stored outside the MFT. MFT record provides cluster addresses where the file is stored on the drive's partition, referred to as data runs. Each MFT record starts with the header identifying it as resident or non-resident attribute. Once again, we'll look at those attributes, and if you're actually digging into MFTs, then this would be something that would require quite a bit of research. So not something that you're just going to sit down and say, oh, let's go through and analyze the hex dump from MFTs. It would take a little time. Now, here we go. We've got a hex dump of the MFT and file attributes, so you can look through that and to see kind of what's contained in there and the designations for each. Each of the over 100 file systems has this type of hex dump. So depending on the file system that you're dumping, it will have a few hundred different attributes that allow you to identify metadata or file locations or types of files. So looking through that, we can see all the information they're talking about. And then, when a disk is created as an NTFS file structure, OS assigns logical clusters to the entire disk partition. These assigned clusters are logical cluster numbers, LCNs, become the addresses that allow MFT to link to non-resident files on the disk's partition. When data is first written to non-resident files, an LCN address is assigned to the file. This LCN becomes the file's virtual cluster number. For the header of all MFT records, the record fields of interest are as follows. and it breaks down how the MFT then is recorded in the hex for each file. So if you want to go through that, that's interesting stuff as far as dumping a hex dump and be able to see in the hex what's actually going on in the file. So there they go. We can look at the hex dump there. A little more hex breaking down where it is. And it carries on. All right. Now, here's something that's kind of interesting. Alternate data streams. Now, alternate data streams, ways data can be appended to existing files, can obscure valuable and evidentiary data intentionally or by coincidence. In NTFS, you can actually store data attached to the file, but not visible unless you know the alternate data stream. So if you want to look up alternate data streams right now, go for it. There is an easy way to do it. It is insanely simple to copy files into alternate data streams that are then invisible to antivirus software. Now, I say invisible, but a lot of antivirus software does include a solution for alternate data streams. It allows you to look into alternate data streams and then pull information down about them. All right, in NTFS, an alternate data stream becomes an additional file attribute, allows the file to be associated with different applications. You can only tell whether a file has a data stream attached by examining that file's MFT entry. So if we look down, the start of data run for second attribute, down here at the bottom, 0x80 location of hidden alternate data stream, right there. So that right there, we will actually look at alternate data streams in just a second. So that is something that is insanely easy to do, and you should experiment with it. If you have an NT box or a Windows box handy, you should go ahead and give it a shot. Okay, we're back, and we have a Windows 7 machine. I think this, yeah, the Windows 7 machine. And we're going to go ahead and create a data stream and look at the data stream. So let's see what kind of files we have here. Type dir, and we've got config.sys. Notice it's 10 bytes. If I type config.sys, it says files equals 40. Now let's go ahead and put something in there. Let's type echo hidden data. I'll go ahead and call it hidden data stream, right? It's an alternate data stream, not a hidden data stream. Alternate data stream, but hidden data stream. I'm going to pop that over into config sys, and I'm going to put a colon there. And I'll make a new file. We'll call it, secret data, or just data.txt, data.txt, like that. Enter. Now let's look at the file. Now as we look at the file, you'll notice that config sys is still only 10 bytes. If I type config sys, it still says the same thing. If I type config sys and put a colon and then do that data.txt, you notice type does not recognize the data in the stream there. Let's go ahead and type notepad config sys colon data.txt, and now inside of notepad you can see that we have a hidden data stream, which is actually just an alternate data stream. These are ways you can actually copy entire files into this. So you can copy a file to an alternate data stream, store whatever information you want there. It works great. Recovering it, there are a couple of different ways that you can get the information back out, but greater than, less than, and then of course if it's text, you have Notepad, and you can send secret messages to your friends. Okay, popping back over to our slides here. NTFS compressed files. NTFS provides compression similar to FAT Drive Space 3, a Windows 98 compression utility. With NTFS, files, folders, or entire volumes can be compressed. Most computer forensics tools can uncompress and analyze compressed Windows data. Encrypting file system, that's the EFS, introduced in Windows 2000, implements a public key, private key method for encrypting files and folders, disk volumes. When EFS is used in Windows 2000 and later, a recovery certificate is generated and sent to the local Windows administrator account. Users can apply EFS to files stored on their local workstations or remote server. Be careful because EFS stores that file on its local unencrypted space. So if you want to recover that, there's a Russian utility that allows you to recover your EFS information. The most popular utility would probably be LCOMSoft. So if you want to look at that, LCOMSoft, they usually have a trial. You can download the demo, try to recover your files without a key. Don't have a key. Try to recover your files. It'll let you know if it can find your files. It'll show you the file names, contents, and then you can go ahead and spend the $150 or $75 or $200, whatever it costs. Okay, EFS Recovery Key Agent. Recovery Key Agent implements the recovery certificate, which is the Windows administrator account. Windows administrators can recover a key in two ways, through Windows or from a command prompt. The commands cipher and copy are the commands there. When a file is deleted in Windows NT and later, the OS renames it and moves it to the recycle bin. Can use delete MS-DOS command, eliminates the file for the MFT listing in the same way FAT does. Now remember, when we type DEL or we delete it, then all we're doing is deleting the pointer to it. The data are still on the disk. Resilient file system, ReFS, designed to address very large data storage needs, such as the cloud. Features incorporated into ReFS design, maximize data availability, improved data integrity, designed for scalability, and ReFS uses disk structures similar to MFT and NTFS. We're going to stop there because that's going to bring us into our disk encryption, and that's going to really get us into another section there. So ending with that, next we'll start up with understanding whole disk encryption. Hope everything's going well, and I look forward to talking to you again sometime soon.